Welcome to the unit on quadratics, completing the square. The objectives for this session are to solve quadratic equations by completing the square. It is sometimes useful to rewrite a quadratic expression by completing the square. This is expressed as x squared plus bx equals x plus b over 2 all squared minus b over 2 all squared. Now, how did we get this expression? We can see this by looking at the two rectangles on our screen on the left-hand side. We have a shape which is a square next to a rectangle. The area of this shape is x squared, as shown, plus b times x. Now we're going to split this b by x rectangle into two parts and position it so that it forms a square, as shown on the right-hand side. Now the shape on the right-hand side and the shape on the left-hand side can be compared. So these two areas that have been highlighted, they both have an area of x squared. However, the rectangle has been split. So the b times x rectangle on the left-hand side is equivalent to the two rectangles, or the area is equivalent to the two rectangles shown on the right-hand side, and their area is 2 times b over 2 times x. So the area highlighted on the right is equal to the area highlighted on the left. The area in the red box highlighted on the right is x plus b over 2 all squared, as you can see. However, we do have an additional square. You remember that the area on the left does not include that little square in the corner. So we have to subtract that from our whole area, as shown, to give us the expression x squared plus bx equals x plus b over 2 all squared minus b over 2 all squared. Now pause the video and have a go at the example on your screen. Press play when you're ready to view the solutions. So let's have a look at the solution to example 1a. We're required to complete the square for x squared plus 16x. How do we plug this into our formula? We begin by plugging in b equals 16 in our formula as shown. And we're left with x plus 8 all squared minus 64. And so we've completed the square. And now for example 1b. Complete the square for x squared minus 5x. In this example, the value of b is minus 5, so we plug this into our equation as shown. And then we tidy up. And so we've completed the square. And now for example 1c, we're required to complete the square for 4x squared plus 10x. However, this example is slightly different as we have a coefficient which is not equal to 1 for x squared. So we factor this out as shown. Now we can deal with the bit inside the brackets as usual. Now here we have that b is equal to 5 over 2. So we plug this in into our formula. And then we tidy up. So we have 4 times x plus 5 over 4 all squared minus 25 over 4. We can also complete the square for a general quadratic by using the formula on the left-hand side of the screen. Pause the video and have a go at the example on your screen. Press play when you're ready to view the solution. Let's now solve example 2. Applying the formula on the left to our example gives us the expression shown on the right. So let's see where we got all those values from. Here we've plugged in a equals 2 in our formula. Here we've plugged in b equals 13. And here we've plugged in c equals 1. And 2 and 4 were part of the formula anyway. So tidying up, we have 13 over 4 here, and we have 1 minus 169 over 8 here. And then tidying up some more, we leave this expression as it is, and this expression simplifies to minus 161 over 8. And so we've completed the square. So what are our values of p, q and r, as was asked in our original example? P is 2, as shown. Q equals 3 1/4, and R is equal to minus 20 1/8. Now pause the video and have a go at the example on your screen. Press play when you're ready to view the solution. So let's solve example 3. We're going to express our quadratic in the form shown by using the formula. So we plug in the a equals 1 in the formula as shown, and b equals 10 as shown, and c equals 15. The 2 and the 4 are part of the formula, so they stay as they are. Now tidying up gives us x plus 5 all squared plus 15 minus 25, and this is equal to 0. And so we're left with x plus 5 all squared minus 10 equals 0. Let's now solve this. So we add 10 to both sides to give us x plus 5 all squared equals 10, and then square root to give x plus 5 on the left-hand side and root 10 on the right-hand side. This gives us x equals root 10 minus 5. Now have a look at this example. Pause the video and have a go. Press play when you're ready to view the solution. So let's solve example 4. We plug in the values as shown in our formula. And then tidy up. So rearranging gives us x minus 3 all squared equals 27. And then square rooting both sides gives us x minus 3 on the left and root 27 on the right, as shown. Now root 27 is actually 3 cubed, as shown. We can write this as x minus 3 equals 3 root 3. And then rearrange to give x equals 3 plus 3 root 3. And finally factorize to give 3 times 1 plus root 3. This brings us to the end of this session. If you have understood its contents, you should be able to solve quadratic equations by completing the square. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to it.